All right, Algebra 1, Chapter 1, Section 2, Finding Cube Roots. The central question to this is, how is a cube root different from a square root of a number? We should be familiar with square root. So if you remember a square root, like if we take the square root, let me get a pen here. Take the square root of 4. Okay. Square root of 4 is 2. We should know that one. It should be memorized. But how do we find that? Well, when we're looking for square roots, we're looking for things that are squared. So if we break 4 down, factors of 4, 2 times 2. So I have the square root of 2 times 2. 2 times 2, something times itself is a square. That's 2 squared. And we can remember this is a square root. There's actually a little index of 2 right here. You're not always going to see that. That one's an understood. So the square root of something squared, those are opposite functions. They actually cancel each other out. It leaves you with just the number underneath, the 2. So we can do that with anything. If we want to square root 16, if we break it apart, well, 2 times 8, break that apart, that's 2 times 4. Break that apart, that's 2 times 2. So I've got 2 times 2 times 2 times 2. That's 2 squared times 2 squared. Okay. We can break those into the square root of 2 squared times square root of 2 squared. Those cancel. 2 times 2 is 4. Okay. We can do that all the way back up this way. If we just circle our pair of 2's, our squared thingies, our squared numbers, okay? I have 2 times 2 right here, that's a square. I have 2 times 2 right here, that's a square. The square root of a thing squared is the base number, so that would be a 2 times a 2, which is 4. Okay, we could even work that a little bit different. If I had the square root of 16 and I broke it into 4 times 4, I've already got that pair, that square that I was looking for, this 4 squared right there, so that's 4. Okay, that's a way that we can do squares. Hopefully we know the rules of radicals as well, as I did back over here where I had this multiplying. You can actually separate that into 2 separate square roots multiplying together. Okay, so let's go back to our essential question. How is the cube root of a number different from the square root of a number? Well, when you multiply a number by itself one more time, or you take it times itself, that'd be 2 of that thing, like a square. Okay, a cube is going to be times itself twice more, so you've got 3 things happening. So if we had 4 cubed, 4 to the 3rd, where the exponent is 3, we get 4 times 4 times 4, which is 64. To undo this, the opposite function of cubing something, like the opposite function of squaring something, is square root. The opposite of cube is cube root. And we write a little 3 index inside the radical sign that let us know that we want to do a 3rd root instead of a square root. This symbol is square root, which could have a little 2 right there if you so wanted it to be. But this symbol is a cube root. Okay. With square root, we were looking for pairs of things. With cube root, we're going to be looking for triples. So if I broke 64 apart, I could break it into 8 and 8. But remember, I'm looking for triples now, not doubles. So I don't have 3 8s yet, so I got to keep breaking apart. I've got 2 times 4 and 2 times 4. I don't have any triples yet. Once you break the tree, once you branch these out and break the tree, those branches are now broken. So if I break the 4 into 2 times 2, there's 3 2s. There's my triple. I break the 4 into 2 times 2. I broke the 4 branch. The 2 branch I haven't broken, so I get to use it with the other 2s. So that's 2 times 2, which is 4. One set of triples comes down to be right here. One set of triples comes down to be right there. That's a cubed thing. A cube root of a cubed thing is its base. Gives me the 4. So let's move through on this. Now the easiest way to do this is with your calculator. Calculator's got a cube root function. You can type in the number, push enter, it'll give you the cube root. But if you need an exact answer for something that's not a perfect cube, okay, cube is a number that when multiplied by itself and then multiplied by itself again equals the given number. A perfect cube is a number that can be written as the cube of an integer. The symbol cube root, or the radical with a 3 index, is used to represent the cube root. Now with square roots we get into this problem where you can't have the square root of a negative number. But with cube root that's not a problem, because when you multiply something times itself 3 times, it could end up being negative. Negative 1 times negative 1 times negative 1 is again negative 1, because these become a positive 1 and those become a negative 1 again. So that's an okay thing. Okay. The quick solve on these is typing them in the calculator, but if you need to do it longhand because you don't have a calculator at home, if we do cube root of 8, for instance, like A there, break 8 into 2 times 4. I don't have any triples. I don't have any cubes yet. This is how many we're looking for. Right here. If I break the 4 apart into 2 times 2, I've broken those branches, they're gone, but I've got 3 2s now. So the thing that is tripled up, the thing I have cubed, is a 2. There is 2 times 2 times 2. It is times itself 3 times. Okay. And remember that if we get the cube root of something cubed, those 3's cancel out and it's just that base number. This also works on the outside. If you have the cube root of something and that whole thing is being cubed, these guys still cancel and it leaves you with just the base number. So we had 2 here. On B, we've got a negative. If your cube root starts negative, your answer is going to be negative. Okay, so I got 27, and I'm cube rooting that. Break it into 3 times 9, broke the branch. Still don't have 3 things, but I could break the 9 apart into 3 times 3. Ooh, there's 3 3's. So it'd be a negative 3. Okay. Now, when we get into fractions, that's definitely going to be a place where your calculator is a little bit better and a little bit more helpful. But if you don't have the calculator, a rule of radicals is you can separate a division inside of a radical into 2 separate radicals. We can do the cube root of 1 over the cube root of 64. Well, 1 breaks into 1 times 1. Don't have 3 of them yet, but 1 breaks into 1 times 1, and there's 3 1s. So that's going to be a 1. 64, 8 times 8, 2 times 4, 2 times 2. Those are broken. I branched out on them. Ooh, I got 3 2's, and I got 3 2's. So a 2 comes out, and a 2 comes out. This comes out as 1 2. This comes out as another. Because 2 times 2 times 2 is 2 cubed times 2 cubed. Remember, these cancel, those cancel, and we're left with just 2 times 2, which is 4. So we'd have a 4 on the bottom, 1/4. If We circled all of our answers like we're supposed to. D, separate that. Cube root 27 over cube root 125. I'm going to get some space back over here. Okay. So this cube root of 27. Break that into 3 times 9. 9 breaks into 3 and 3. There's my 3 3s, so a 3 on top. 125. It ends in 5, so 5 should go into it. 5 goes into it. Let's see. 25 times. No triples yet. So we're going to break 25 apart. 5 times 5. There's a triple. So 5. That's how you can do that long-handed. Okay, you only need to do that if you don't have that calculator with you, but it is a good skill to have and be able to practice. You'll need that in Algebra 2 as you move along. So let's try a couple more. Okay, there's that 1 again. 1 times 1, 1 and 1, 3 ones, 1. This one's going to be negative. We can just ignore the negative sign to do the 343. Well, let's see. Does 3 go into that? A way to tell if something is divisible by 3 is you add all of the parts up, and if that's divisible by 3, then the original was divisible by 3. So 3 plus 4 is 7, plus 3 is 10. 3 does not go in to 343. That's unfortunate. Let's see what that means. 6 doesn't. It means 9 doesn't. What goes into 343? Let's see. 343. 5 doesn't. 4 doesn't. What about 7? Can we try 7? Let's see. 7. If I just divide 343. Let's see. 4 times is 28. 1, 2, 5, 63 would be a 9. Okay, so 49 times 7 and 49. Don't need that anymore. Okay, but I don't have a triple, but I can break 49 apart. That's 7 times 7. Oh, that worked out nice. Got 7. Answer is going to be negative. We're going to do 2 different ones. Cube root of 27. Cube root of 1,000. Break that. 3, 9. Breaks into 3 and 3. Ooh, that goes quick. Okay, so 3 on top. 10 times 100. 10 times 10. Oh, we've got 3 tens. We can stop right there. If you get 3 of a thing, you can stop early. Now with this one, I could have, and I'm going to do it in a different color so you can see the continuation. I may not have seen the tens. So maybe I break that into 2 and 5. Break that into 2 and 5. Break that into 2 and 5. Okay, well I've got 3 2s right there. And I got 3 5s. So that's 2 times 5, which is 10. Either way, you're still going to end up getting back to what the answer is, what the cube root actually is.